Hi everybody, we're just going to finish off 2 part 1 and then we're going to continue on with 2. It's a longer section. And the last one there we didn't get time to do was the tan of 330. Remember, click back to our cast summary chart there. The tan of 330, remember in quadrant 4, cos is the only one that's positive, so when we refer back to our reference angle, you just do the opposite sign. So tan of 30 is root 3 over 3. As you can go back to your chart to get that information. I'll show you where that comes from. So just scroll back to here, right? So 330 would be equivalent to 30. And if you're not sure of that, remember, go back to your math reference angle. I'll show you that link. So gotta go back. So we got 330 has a reference angle of 30. So that's where that comes from. All right. And remember, tan is positive as 30 up here, and it's negative down here. So that's why it's equal to the negative of that value right here. So that's 3 over 3, or 1 over root 3. Scroll back down. So that's why it's negative. Just put a negative in front. There's your exact value, which is pretty neat. And you can check those again. Root 3 over negative root 3 over 3. So remember, the tan of 30 is going to give me 0.5773. So that means the tan of 330 should be the negative of that value. And yes, it is. And again, if you want to make sure you use the proper exact value, just with your negative, second function square root 3. I hit my right, that'll get rid out of the radical sign divided by 3, and that should be equal to the same thing. And yes, it is. They are equal. Okay? So try some of these. There's some practice questions that go with the first part of 2.2, and that homework comes from the textbook on page 96. 1 through 8 and 11 through 13 are examples pertaining to the cash rule. Get yourself familiar with those. All right, next we're going to move on to page 14. It's I call it the second part of 2.2, and it's quadrantal angles, and so we're going to look at some equations for solving the theta value. All right. Again, we're trying to use no calculator here. I just use it as a way to show whether it's correct or not. So quadrantal angles are angles in the standard position whose arm lies on the axis. So we obviously know these are 0, 90, 180, 270, 360. So they're not oblique. They're either running horizontal or vertical. So there's 0 degrees. We got a horizontal positive x-axis. We have 90 degrees, which is on the positive y. We have 180, which is on the negative x, and we have 270, which is on the negative y, and then obviously 360 and 0 are equivalent because we're back to where we started. Remember these values here. We have the sine of theta is y over r, cos theta is x over r, and tan theta is y over x. Don't get confused again, because it depends on the orientation of your triangle, right? So sometimes you'll think it x, but it's not really. It's just because the angle is in a different location, right? It's just the orientation. So I filled this chart in based on what's above here. So we're going to summarize these. So remember, sine is why does the sine of 0 equal 0? Remember, it's the y over the r value. So in this case, the y value is equal to the r value, or sorry, the r value is equal to the x value. So that's why we have the y over r, x over r, right? So 0 degrees, 0 over r, right? R is equal to x, so it actually ends up being y over x, or y over r, and it's 0 over r. Okay. This is just showing where it comes from. You don't need to commit those to memory. But this is where the values come from. So sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is negative 1. The sine of 360 is 0. Instead of just punching in the calculator and getting these values, you use this diagram here, this reference, to show how they're calculated. So it's just where they're coming from. Okay. And again, the r value is equal to an x or y, or due to the fact that there's no oblique, right? There's no angle coming off here in the quadrant. It's directly on the axis. Okay. Let's apply some of these. So it says find the exact value of cos of 90. So remember, cos of 90 is equal to x over r. X would be 0. Y would be r would be y. So it's 0 divided by n would be 0. Sine of 270 is y over Again, this is more of an exercise designed to help with the understanding. Okay. And then the last one is tan 180 is y over x. Y is 0 over negative x. 0 divided by anything other than 0, of course. So 0 divided by negative x is obviously 0. Okay. So solve the following if our values are between 0 and 360. Use the special triangles when possible. So if I see that the sine theta is equal to 1/2, I got to say, oh yeah, I remember a half. So then I got to look at my special triangle that has the 1 and 2 in it, which is 30, 60, 90, and 1, 2, root 3. I commit these to memory, but they're very simple. Take your smallest angle. Side opposite your smallest angle is 1. Your hypotenuse is 2, and it's root 3. Again, I'm going to give you the chart at the very beginning of the booklet right here. I give you this when you have your assessment in grade 11 and grade 12. Again, it's good to commit it to memory because you don't know what your prof is going to have, but there they are. Again, once you practice these, they you kind of just remember them anyway. And again, you can check them on your calculator. So we're going to head down to, here we are, sorry. So 1 over 2, 1 over 2, that's opposite. Remember, sine is opposite, so opposite of 1 is 30, so we know the reference angle is 30. So when does the sine of an unknown angle equal 1/2? It's not just once, it's actually going to be twice. The other one is going to be the 150. And this is where you got to go back to your cash flow. What other quadrant is sine positive? We know it's in quadrant 2. Again, referring back to our little summary here, sine is positive in quadrant 1 and quadrant 2. So the other angle would be 150. If you're still unsure, grab this little neat little program here. Remember, we're dealing with the sine of 30, so we're looking for a reference angle of 30 in quadrant 2. So we keep bringing it over, and 30 is obviously 150, because they're equal, right? So the sine of 30, which is over here, and the sine of 150 are equal, again, because that's summary. Any sine in quadrant 2. Again, you can check them again. Sine of 30 is going to give you decimal 5, and the sine of 150 is going to give you decimal 5. So, just as an extension, what would the sine of an unknown angle give you? Negative 1/2. If you guessed quadrant 3 and 4, you would be correct. So it would be sine of 210, because I'm adding 30, my reference angle, to the 180. Yes, it's negative 1/2. And then the fourth quadrant, reference angle of 30 would give us 330 as our quadrant 4 angle. That would be equivalent. And again, it's a negative 1/2. All right? So you have two signs that are positive, and you have two signs that are negative, right? And it's always going to be your angles in quadrant 1 and 2 are positive, and quadrant 3 and 4 are negative for sine, right? We know cos 1 and 4 are positive, 2 and 3 are negative. We know tan 1 and 3 are positive, 2 and 4 are negative. All right, so that's how it's all related. Let's go back to answer our question. So the two angles, those notes have theta I, that's quadrant 1, is 30 degrees in quadrant II, which is Roman numerals for 2. That's quadrant 2, which is 150. They'll both give you back the 1/2, like I showed you on your calculator. So let's do the next one. Sine of theta is equal to 1 over root 2. So they haven't rationalized the denominator, which is fine. It's actually easier to do it this way because it relates directly to the triangle. So 1 and root 2, you got to remember, oh yeah, that's a perfect triangle, 40 with 45s. So we can pick either one, it doesn't matter. So I'll pick this one up here instead. So it's opposite, which is 1, over hypotenuse, which is root 2. So we know we're dealing with the 45, so our reference angle is 45. What other quadrant has a reference angle of 45 that yields a positive value for sine? When we take the sine of that unknown angle, and you rewrite it's quadrant 2, and that angle is 135. And again, we can go back to this, and we got the 45, 135, right? I like this little program. It's neat. And that program is the site. Again, I'll make sure I put that in when we start next week. I'll make sure I copy that link in for you. But it's just math mathopenref.com. mathopenref.com. Okay, neat little program, or I shouldn't say program, little way of working. So cos theta root 3 over 2, but it's negative. All right. So in this case, again, when we have the square root of 3, you know you're dealing with special triangle 30, 60, 90. So if it's the negative doesn't make a difference, just I basically hide the negative for now. That'll get our reference angle. So don't even look at that at this point. And what we're going to do is we have the adjacent, right, of 30. So it would be root 3 over 2. So we know we're dealing with a reference angle of 30. That's not going to be one of our answers. That just gives us our reference because we know that it has to be negative. So cos is negative in quadrant 2, in quadrant 3. As you refer back up to your summary here, right? It's right here. Okay. So when we refer back to that summary, we know that our reference angle is obviously 30 based on the special triangles, and your two values are 150 and 210 because 30 has a reference angle. 150 has a reference angle of 30 in quadrant 2, and 210 has a reference angle of 30. All right, and you play with that little website I showed you to help you look at those until you get the hang of it. That's pretty neat. Again, I'm going to show you how to calculate this too, another little cheat, not cheating, but a way to reference this. So if I went to my calculator and I said the arc cos, because we know we solved these before, and we don't put in the negative, just put in a root 3 over 2, and that'll give you the reference angle. So second function, square root 3, make sure you arrow right, divide by 2, close your bracket. So we're taking the inverse, which is the arc, right? So we're taking the opposite. That's how we did this when we calculated it earlier on and in grade 11. And then we get 30. You see the 30 coming in, right? And then, so when we take the cos of 30, that'll give me negative root 3 over 2. Or negative, positive decimal 8660. But we were looking for the negative of this. Remember, root 3 over 2 is equal to decimal 8660. So if we took the cos of 150, we know it's going to be the negative of this value. And yes, it is. And if we take the cos of the reference angle, 210, or the principal angle 210, which we know has a reference angle of 30, that'll also give you a negative decimal 8660. And then if you went to your fourth quadrant, which we know is 330, which we know would be positive for cos, it'll give you the positive decimal 8660. So just another way to check. Love leaving a question knowing I can't get it wrong, because there it's bang on. You can just check, right? So, but you will be asked to do these without a calculator, so that's why I'm showing you with the special triangles. Tan theta is equal to 1. Remember, we know tan theta is equal to the opposite over adjacent. So regardless of what side you pick for 45, it's going to be 1 over 1, which is 45. We know tan is positive in quadrant 1 and quadrant 3. So we know that 45 is our reference angle, which is also our quadrant 1 angle, and our quadrant 3 angle would be 225. Again, you can flick back to this, which is nice, and you get your 45. Positive here, and positive here. The next two, cos theta is equal to 0. So when is cos theta equal to 0? We know it's at 90 and 270. We get that again from the chart we just created. Cos of 90 is 0. Cos of 270 is 0. And that's because what you see here, it's 0 divided by your y value, right? Because it's x over r, but there's no x value because it's right on the horizontal. All right? And again, we can check these on the calculator. Well, I wouldn't mind plugging this in. So remember, to get your angle, you take the inverse, which is the inverse second function, cos of 0, which gives you 90. And that'll also have for the cos of 270 as a check. You go back, cos of 270, you go back 0. So I only got 10 seconds left here. So we'll pick it up again in the next video.